Welcome back, dear students. Let us continue the practical problems on union and intersection of sets. Okay, so these are real life problems. There we will use the set concepts. Okay, so in that, first one, see some basic formulas. Okay, first, if A and B are two non-empty disjoint sets. If A and B are two non-empty disjoint sets, so it means intersection of A and B is null set, right? There is no element in the intersection of A and B, A intersection B. So using that, number of element in A union B is equal to the, so the formula is number of elements in A union B is equal to the number of elements in A plus number of elements in B. This is the formula when if A and B are two disjoint sets. When A and B are two disjoint sets. Okay, then disjoint set. Suppose if A and B are finite sets, then number of element in A union B is, so they are not disjoint here in the second case. Number of element in A union B is number of element in A plus number of element in B minus number of elements in A intersection B. Number of elements in A intersection B. Very important formula. So number of elements in A union B is equal to the number of elements in A plus number of elements in B minus number of elements in A intersection B. Right. Third formula. Okay. If A, B and C are finite sets, so then in number of element in A union B union C, okay, this is equal to the number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B. Okay, number of elements in A intersection B minus number of elements in A intersection C minus number of elements in B intersection C plus number of element in A intersection B intersection C. Okay, this is the formula when if you have a three sets. Okay, number of elements in A union B union C is equal to the number of element in A plus NB plus NC minus n of A intersection B, n of A intersection C, n of B intersection C plus n of A intersection B intersection C. Okay, so these are the three basic formulas we will use the calculate some problems. Okay, so see the question example 23. If X and Y are two sets such that X union Y has 50 elements. Okay, X has 28 elements and Y has 32 elements. How many elements does X intersection Y have? Okay, so see the question, very basic and important questions. These are all for 3 marks. Okay, X and Y are two sets such that X union Y has 50 elements, that is number of elements in X union Y is equal to the 50, right, given. Next, X has 28 elements, means number of elements in X set is 28. Then Y has 32 elements, number of elements in set Y is 32. Okay, then how many elements does X intersection Y? That is number of elements in X intersection Y is equal to the question mark. Okay, so we know three quantities, only one is unknown, we have to find this one. For that, use the formula number of elements in A union B. This formula I will use. Okay, we have x number of elements in x union y is equal to the number of elements in x plus number of elements in y minus number of elements in x intersection y. Okay, in this we know this quantity, this we know, but this is unknown, we have to find this one. Okay, so then take this to the this quantity to this and this to this side. Okay, that becomes n of x intersection y is equal to n of x plus n of y. So this come to RHS means it will become negative n of x union y. Okay, so fill the n of x value 28 plus n of y value 32 minus x union y, this is 50. Okay, 28 plus 32 is 60 minus 50, this is equal to the 10. So number of elements in x intersection y is equal to the 10. So therefore, so conclusion is x intersection y has 10 elements, and hence x intersection y has 10 elements. Okay, so this is a very important problem for 3 marks. Okay, next example, example 24. In a school there are 20 teachers who teaches mathematics and physics. Okay, so among the 20 teachers, some of them will teach mathematics and some of them will teach physics. On these 20 teachers, particular teaches mathematics and 4 teachers teaches only physics, both physics and mathematics. Okay, so how many teaches physics only? We have to consider the question 20 teachers among the total 20 teachers who teaches mathematics and physics. That is, or means we have to consider always union only. Or means always we have to consider union only. First denote this m by mathematics, and p by physics. Okay, in this number of lectures who teach mathematics or physics. R means always we have to consider union. Okay, so then m union p, this is equal to the 20. M union p is equal to the 20, and number of lectures teaches mathematics particularly is 12. That is nm is 12, and 4 teaches both physics and mathematics, and means we have to consider always intersection. Okay, R means union, and means intersection, compulsory. Okay, then number of lectures who teaches mathematics and physics is 4. Now we have to find how many teaches only physics, that is number of physics teachers, question mark. Okay, consider the same formula for the previous problem we have considered, that is n of m union p, this is equal to n of m plus n of p minus n of m union p, m intersection p. Then we know n of m union p and n of m we know, this we know, n of p we have to find. Okay, n of m intersection p is also we know. Okay, substitute all the given, this is 20, n of m is 12 plus n of p as it is, we don't know this, so we have to find. Then n of m intersection p is 4. Okay, so 20, this is equal to 12 minus 4 is 8, right, plus np. N of p equal to the 20 minus 8, this is equal to the 12. N of p equal to the 12. Therefore, hence 12 teach physics only. So among the 20 teachers, 12 will teach only physics. Okay, see next question. Example 25. In a class of 35 students, 24 like to play cricket and 16 like to play football. Also, each student like to play at least one of two games. Okay, how many students like to play both cricket and football? Okay, see the question. X means solution. I will take here. X means, so students who like to play football, I will consider. Okay, and Y means, so Y I will consider here. X means cricket, you consider please, cricket. Okay, Y means football, Y is football. Next, X union Y, X union Y is, so at least one game. Okay, at least one game who like to play. Then X intersection Y is both games, so this gives both games player numbers. Okay. So now write the given. Number of players who play the cricket only is 24. 24 like to play cricket and 16 like to play football. Number of Y is 16. Then we don't know, so X intersection Y, both, that is X intersection Y, number of students in both the games, X intersection Y, and total number of students is 35, that is number of X union Y is 35. Okay, we got three quantities, only one is unknown. Use the formula, that is n of X union Y is equal to the n of X plus n of Y minus n of X intersection Y. So we need n of X intersection Y. This we know, these are the known quantity, last one is unknown quantity. N of X intersection Y is equal to the, okay, n of X plus n of Y. So this I take to the LHS, so it will go to the RHS, it becomes negative n of X union Y. So this is equal to n of X is 24, n of Y is 16 minus union is 35. So this is equal to 24, 16 is 40. Okay, 40 minus 35, this is equal to 5. Therefore n of X intersection Y equal to the 5. So among the 35 students, 5 students will play both cricket and football, and word is very important, and means intersection. So among the 35 students, 5 students will play both cricket and football. Okay, example 26. In a survey of 400 students in a school, 100 were listed as taking apple juice and 150 were listed as taking orange juice. Okay, then 75 were listed taking both apple as well as orange. Okay, then this is both 75. Find how many were taking neither apple juice nor orange juice. Okay, neither apple nor orange means we go through the complement. Okay, first write the given. U, surveyed students union sets I will consider. In that, A is apple juice taking students, B is orange juice taking students, Okay, number of students in the universal set, that is 400, and number of students who are taking apple juice, 100 were listed as taking apple juice, that is 100, and number of students taking orange juice, that is 150 students are taking orange juice, 75 were listed as taking both, okay, that is n of A intersection B, that is 75. How many students were taking neither apple? Neither apple means apple juice means A, neither apple means A complement, that is n of A complement intersection B complement. This is we need, so this quantity we need first, okay. So I will write n of A dash intersection B dash equal to the n of A union B whole complement. Using the De Morgan's law, A dash intersection B dash complement equal to the A union B complement, right? This I will write as a n of U minus n of A union B. So complement is nothing but a union set minus this set, subtraction from the universal set, n of U minus n of A union B. So call this equation as a 1. In this we don't know A union B in the given quantity, so first find A union B and substitute in this n of A intersection A dash intersection B dash, okay. So go through the as usual formula, that is n of A union B equal to the n of A plus n of B minus n of A intersection B. So n of A union B is the unknown quantity, n of A is how much? N of A 100, okay, then n of B is 150 minus n of A intersection B is 75. So this is equal to the 250 minus 75 is 175. So number of students in A union B is 175, okay. So take equation 1. Now equation 1 becomes n of A dash intersection B dash, this is equal to n of U minus n of A union B, okay. N of U, universal set contains 400 students, 400 minus 175, this is equal to 225 n of A dash intersection B dash. So therefore 225 students are taking neither apple juice nor orange juice. So this is the conclusion of the problem, okay. So these are all very simple problem attached to our daily life. Using a set concept we will solve these problems in this way. Example 27, there are 200 individuals with skin disorders, okay. 120 had been exposed to the chemical C1. Among the 200, 120 are exposed to the chemical C1 and 50 to chemical C2. So 120 have the skin disorder from the chemical C1 and 50 from the chemical C2, and 30 to both C1 and C2. Among the 200 members, 30 exposed to the both skin disorders, that is from chemical C1 and chemical C2. Find the number of individuals exposed. So first one is chemical C1 but not C2. Second one is chemical C2 but not C1, and third one is chemical C1 or chemical C2, okay. So there is a little difference in the question from the previous questions, okay. So there are 200 individuals, okay. Total number of individuals in this is, that is union, I will consider, universal set and consider total individuals, okay. A I will consider as a exposed to C1 chemical C1 exposed to the C1 and B as exposed to the C2. First write the given. Total individuals are N of U, that is 200, and A C1 chemical exposed individuals N of A is 120 and N of B, that is exposed to the chemical C2 50. Okay, 50, and both 30 to both C1 and C2, that is N of A intersection B, that is 30 members exposed. This is the given. Okay, so now we have to find. First one is, I'll write here, see, chemical C1 but not C2, that is exposed to the A, that is A but not B, means number of A minus B we have to find. A but not B, C1 but not C2. Second one is C2 but not C1, that is B minus A we have to find. Okay, third one is C1 or C2, or means always union, N of A union B we have to find. So these are the three quantities we have to find now. So see Venn diagram for this question first, that is, so already you know this universal set A, and this is set B. This area represents A intersection B, this area represents A minus B, and this area represents B minus A. So see here, these three areas are all disjoint, means intersection of any two areas will give you a null set. Disjoint means intersection of any these two will give a null set. Okay, so go through the first one, N of A minus B. We need N of A minus B. Okay, so A minus B intersection A intersection B is, that is A minus B intersection A intersection B. This will give you the null set, because those two are disjoint sets. Okay, we need N of A minus B. This is equal to the N of A minus B is nothing but N of A. So see here, N of A total this area minus intersected area minus N of A intersection B. Okay, so formula for A minus B is, using the Venn diagram, A minus B is equal to the total A minus intersected A intersection B area. Okay, so write the given N of A, that is 120, N of A intersection B is 30. Okay, so this is equal to the 90. Therefore N of A minus B is equal to the 90. This means, so number of individuals exposed to C1 but not C2 is 90. Okay, this is first one, N of A minus B is 90. Second one, N of B minus A. Second one, N of B minus A is equal to the, so this is equal to this here, B minus intersected area, means we will get a N of B minus A. In the total set B, if we subtracted intersected area, we will get a B minus A, that is N of B minus N of A intersection B. So what is N of B? Given is there 50 and intersected is 30. This is equal to the 20. So conclusion for this is, number of individuals number of individuals exposed to C2 means second question, that is C2 but not C1, C2 but not C1 is 20, right? Third one, very simple, third one. So n of A union B, n of A union B, so exposed to A or B, C1 or C2, that is the formula n of A plus n of B minus n of A intersection B. This is equal to n of A is C, so n of A is 120, n of B is 50 minus n of A intersection B is 30. So this is equal to the 120 plus 170 minus 30, this is 140. So number of individuals exposed to the C1 or C2 is 140.